For these next few videos, we'll look at properties of fractions. Let's start by looking at how to simplify fractions. We'll notice that there are often multiple ways to write the same fraction. For example, in our rectangle here, if we assume that all of the squares here are the same size, we can see that we have 12 squares total. How many of them are red? 1, 2, 3, 4, 5, 6. We could represent this fraction as 6 over 12 of them are red. However, if we look at this as columns, 1, 2, 3, 4 columns, we can see that 2 out of 4 columns are red, or indeed 1/2 of the entire rectangle is red. These expressions are all equivalent because they all describe the same quantity. We say a fraction is fully simplified if we can't use any smaller numbers to represent that same fraction. We do this by canceling out any common factors between the numerator and denominator. In that last example, we saw that 6/12 was the same thing as 1/2. And how do we know that algebraically? Well, we know that there's a factor of 6 in the numerator that we can divide by, and there's a factor of 6 in the denominator that we can divide by. And as long as we're dividing by that same factor and still getting whole numbers, then we can simplify a fraction. Let's practice. Let's fully simplify the following fractions. 120 divided by 160, we need to look for factors in the numerator and denominator that we can pull out. One of the most obvious ones at this stage is that we can divide both of these by 10, since they both end in a 0. 120 divided by 10 is 12. 160 divided by 10 is 16, but we can keep on simplifying. We can see that both of these are divisible by 2. So we can divide the numerator and denominator by 2 to give us 6 over 8. And in fact, both of those can be divided by 2 as well, giving us 3/4. Once there's no other numbers that we can pull out of both the numerator and denominator, we say that a fraction is fully simplified. However, let's write this one again, 120 over 160. That took 3 steps. We can do this in fewer steps if we recognize that both our numerator and denominator can be divided by 40. If we do that, 120 divided by 40 gives us 3, 160 divided by 40 gives us 4, and we can do the same simplification process in just one step. Let's look at the second one, 3 divided by 7. Well, the only numbers that divide 3 are 1 and 3. The only numbers that divide 7 are 1 and 7. And dividing by 1 isn't going to do anything for us. So we say that 3/7 is already fully simplified. Some of them are a little more tricky. Let's take a look at 168 over 252. I don't know any big numbers that divide both of those, but I do know that both of them are divisible by 2 since they're both even. 168 divided by 2 is 84, and 252 divided by 2 is 126. Both of those are even as well, so they both divide by 2. 84 divided by 2 is 42. 126 divided by 2 is 63. And both of these are divisible by 7. 42 divided by 7 is 6. 63 divided by 7 is 9. And then we've got one more step. 6 and 9 are both divisible by 3, giving us 2/3. 168 over 252 is 2/3. Now, if your brain is bigger than mine, you could have done this in one step right from the beginning, 168 over 252. If you recognized, hey, both of these are divisible by 84, then you could have jumped right to 2/3. But there's no shame in taking several steps to get the right answer. You have to make sure that once you reach an intermediate step, like 42/63, you don't just stop there. You have to check to make sure that it's fully simplified, that you get something that can't be reduced any further.